Hello everyone, for this video we're going to talk about logistic regression. Now what is exactly logistic regression? Logistic regression is a statistical method used for binary classification problem where the goal is to predict the probability that an instance belongs to a particular class. Despite its name, logistic regression is used for classification, not regression. Okay, so it is used for any classification problem where we have to predict that there is a possibility this might happen, and so for that instance we have to predict the probability so that we could come up with a solution that if that item set is going to be there or not. So suppose we have a spam filter for an email, and we have to predict whether a email is spam or not spam. Okay, so as logistic regression main focus is working on categorical values. Okay, so we whenever we talk about logistic regression, it has to have some categorical variables, and so here also you can see when we predict that is the email a spam or not, you could see that it is a categorical thing, that it is either 1 or 0 based on the feature. Okay, so this is how we would work with it, that for that instance we have to decide, we have to predict the probability of email being spam or not. Okay, so so that it could belong to a particular class, so that we could say that the email is spam or the email is not spam. Okay, so rather than if even if the name is regression, it is used for classification. Okay, so for the uh, so for the is it visible? I think it is. Okay, thank you so much. It's visible. So here is logistic regression. Again, we have used our modules that you can see here. Then we have read our value. Then we have dropped the values which are activity profile and ID, because that is not required, as we right now just need, we are working on a target value or target variable. Okay, so we have dropped the unimportant ones which we think would be a little inconsistency in our data set. Then we encode it because it is category, so we have to encode our variable, and so we have encoded it. Then we have defined the feature and target value. We have firstly dropped our drop the sleep profile which is our target value, and then we have taken it in another one. Then we split the data into training and testing set. Okay, so training and testing sets are for prediction. Okay, so training and testing, so the training is the one we are supposed to train, and the testing one where we have to test the sets. Okay, so for next is our logistic regression model. We have firstly used the logistic regression function where here the log reg model, and then we fit it. Obviously for a model we have to fit distinct model. Then we make prediction about it, then evaluate for a logistic. Obviously when we create a logistic model, and then the next step is for our evaluation to see that if our logistic regression is perfect or not, is it efficient, is it working accurately. For that, first we generate the accuracy score, then the confusion matrix, then the class report, classification report, and finally we all print everything that we need. Firstly, we see the accuracy which is 0.8, then confusion matrix, and finally the classification report which has precision, recall, F1 score, and support. And through this, we can go through the whole logistic regression. Okay, and we firstly divide the feature and target variable, then split the data into training and testing, then fit the logistic regression, finally evaluate it to get our accuracy. Okay, so the uh, next is Poisson's regression. So it is used for modeling count data. So we have when we have to represent a number of event or occurrence of any item set in a fixed amount of time, we use Poisson regression. Okay, the Poisson regression is commonly used for count data, and Poisson regression is extended to regression modelings. Poisson regression is commonly applied to various fields where count data is prevalent, such as epidemiology, insurance, and social science. Okay, so if we know the occurrence of number of events, we could get a estimated coefficient, their significance, and how good how how accurate it's and how it fits our statistics. Okay, so for that, for counting all our variable counting data and how much it occurs, we use Poisson regression. Okay, so for the code, here you can see, let me just go with it. Okay. Here you can see that we have again taken our modules, then read our data, then dropped the inaccuracy variables, and then used the integer type. Okay, so the total minute asleep was in a float variable, and so we just ensured that it could be that is changed into integer type. Then sleep profile, obviously it was a categorical value, so we just encoded it. Then again we defined the feature and target variables that you can see here. Then added the constant terms so the for to the features for the intercept, and finally we converted so that it could be used for our Poisson fit, because Poisson fit needs arrays to go with it. And then through the GLM, which is from the state model API, the Poisson model is fit, and then finally we print our summary and get a generalized linear model regression uh, result. Okay, and after this we have model evaluation. Okay, so what exactly is model evaluation? When it comes to data science, it's one of the most important part of our data analysis, data mining. Okay, so as we go through all the steps, model evaluation comes as a very significant feature. Okay, so the process of model evaluation is that now that we have created our models, it is for us to check that how much efficient and how much accurate is our model. If it is not, then we again have to change the model, and through various threshold values and how it changes our how it reaches our significance, our goals. So that again model evaluation is to check the performance of our modules, that that if the goal that we set prior at the starting stage is being reached or not. So it could be through metrics. It involves various metrics like accuracy, precision, recall, F1 score, and mean square error. Through this, we could go for model evaluation. It could also uh, uh, be concerned through cross validation confusion matrices, and the goal is to ensure the model generalized value and avoiding the overfitting and underfitting. So when it comes to model evaluation, it generalizes the whole thing. We do not have to go for overfitting or underfitting, so that we could finally reach the goal that we have set, and it could ensure the performance. uh, Through modeling evaluation, we could judge other adjustment that could be done for specific domain requirements. Okay, so for the next code, we could see here, we had model evaluation. Again, we did all the uh, you know modules. Then we read our um, uh, data set. Then we did all the things like data cleaning and stuff to get our data check. And then we check the independent variables, then the dependent variables. I mean, independent variables which are not correlated to anyone, and dependent variables which are correlated to anyone. Okay, and then we again split the the sets to for training set and testing set. Then we standardize our model and then transform it. We do a logistic regression, and finally, through logistic regression, next we got a model. And to check now the accuracy of this model generated, we firstly do the accuracy score that you can see here, the print classification model accuracy that you can see. We imported the skykit plot, and we would create a plot confusion matrix. Then again, we would go for average precision code, that you can see average precision code, because model evaluation needs next step is average precision score. Then we would go for F1 score. As for the next metric, it is F1 score. And then we would plot all the things that we have generated from here, that the FPR, TPR, and the threshold, and a and finally a target name, so that we could get a true positive rate and false positive rate. You could see here that we have created an independent feature data set, and we had the dependent data set. Then we had the target. We created we You can see here the classification model accuracy, the precision model accuracy, that they are very close. I mean, the accuracy, the precision recall, the F1 scores, all of them are very very congruent. I mean, very close to each other. And we have here macro, micro, F1, and weighted F1 square. And we had the the ROC ROC curve that you can see here of the heart attacker classifier. So through this, we could conclude that firstly we created a model through logistic regression, and finally we went with the model accuracy. In the same way, we have our stepwise regression. Now, what exactly is stepwise regression? Stepwise regression is a method used in statistical modeling to automatically select a subset of predictor variables for a uh, from a large set. The process involves iteratively adding or removing variable based on statistical criteria. Stepwise regression is used for variable selection to build simpler and more interpretable. So, for a very simpler and interpretable model, we use our stepwise regression method. It is used in statistical modeling, and so it could create subset of our larger set, and could reduce the amount of and add or remove variables which are required based on our criteria. Okay, so how do we go with it? We use, as you can see in the code, we again went for our modules, then read, Then the response, we define the response variable. Response variable is the variable through which is our target variable. It could be said as a target variable. Then we had our predictor variables, which are vehicle and fuel and distance in kilometers. Then we dropped the vehicle ID because it wasn't required and it was an inconsistency. Then the fuel type, as it is a criterial value, so we wouldn't go for it. We have to encode it. And finally, we would go with forward stepwise selection. So when it comes to stepwise regression, it has two methods. One is forward stepwise selection, and another one is backward stepwise selection. For this, we had forward stepwise selection. We had a function named forward stepwise selection where we took the x value and the y value, which was firstly the response variable and the predictor variable, and then we selected variables were there, remaining variables. We set a column of we set the columns of x. Then while we had the remaining value, we created a model. So you can see here we have created the forward stepwise selection where we create subsets. That you can see we have created a subset, added constant and used OLS and appended. We have sorted the value and returned the selected variables. Then we have performed the stepwise selection again here. Then fit the final model into the with the OLS to get our selected predict to get our final model summary. Okay, so after this there is a thing called estimated model evaluation. Okay, so it is same as it could be said as a model evaluation in a broader set. If we I mean, it is a subset of model evaluation only. It just take the values, as in it just take the values, estimated values in uh, in a in our training set. Okay, so when we make prediction in the training set, again we took the final model and predicted it. Evaluate the model, obviously we have to take the r squared and then mean square. Then we the r square, we have taken the mean absolute error, we have taken mean squared error, and finally root mean squared. Now these are all estimated values. Okay, so we firstly when we consider estimated value, we would always take the mean of it, so that it could be easier for us to estimate, because we are taking the predicted values on the training set. Okay, so through this we could see the regression results and all the standard values, and here you could see the r squared value, the mean absolute value, absolute error, the mean squared error, and the root mean squared error. Through this we could see all the values and reached a result. Okay, all in all, we have worked with uh, logistic regression, then poison regression, then model evaluation, and finally stepwise regression. And so with this video, we have came to a conclusion. Thank you so much.